my name is Matt Kimo, and today we'll be going over this logical equivalence proof. So what we ultimately want to do is show that this left-hand side is equal to this right-hand side through a series of steps that we can justify. So the very first one, I've gone ahead and rewritten our original left-hand side just with justification of given. And then now what our first initial step is, we see this or, we see this and we want to try and distribute this or across this and see what that gives us. And remember that when you distribute an or across an and, you end up with two or statements joined by an and. So what we're going to get is this negation stays out here. We get P or not P and P or Q. And the justification for this is just distributive law. And then so after that, now we see that we have this statement right here is kind of interesting. We have P or not P. And this, regardless of what P is, P could be true. If P is true, then we're going to get true or false, which ends up being true. If P is false, we're going to get false or true. So regardless of what P is, this statement right here is always true. And this is told to us by the negation law, where if you have a variable with its negation or, if you or it with its negation, you're going to always get a true. Sorry, not negative. Negation law. So here we're going to keep the negation outside. We're going to get T for true and P or Q. So then here, it's interesting because we have true and another statement. So regardless of what, like true is irrelevant here because we have an and with it. So true and this statement entirely depends on the truth value of the P or Q. The truth value right here has no effect on the final truth value of the whole statement. So we can kind of go ahead and just effectively eliminate it. And that's the identity law. So negation law justifies this line. Identity law is our justification for the next line we're about to do, where we just essentially get rid of this truth and, because the truth and has no effect on the final truth value of the statement. So we end up with the negation of P or Q. And finally, right here, we have one final step to get to our final goal, which is not P and not Q. And this one you may see where you just simply want to distribute this negation across the or, and that's simply De Morgan's law. So De Morgan's. And then after that, we've shown that our left-hand side is ultimately equivalent to our right-hand side. So finally we get not P and not Q. And then our proof is effectively done. Thank you.